Today we are going to know a very important fact regarding the temperature. The common people say that temperature is the measure of hotness or coldness of a body, and think that this temperature will depend on the frame from which the observer will observe the temperature or measure the temperature. But it is a misconception. I would like to clarify this misconception in this short video. So I have written here, you can see, does the temperature of a body depend on the frame from which it is observed? It means, does this temperature depend on the frame of the reference from which the observer measures it? The answer is no. It means temperature is not a relative quantity. It does not depend on the reference frame from which you measure the temperature of a body. Okay? So I have written that temperature of a body does not depend on the frame of the observer. You can take a very important example that the astronomers have measured temperature of lots of stars far away from the earth. But when the astronomers measure the temperature of the stars, they do not take into account the fact that the stars are moving towards the earth or away from the earth. It does not matter. It means if temperature will depend on the reference frame, then the astronomers must take into account the fact that the star is moving towards him or moving away from him. But since it is found that this fact does not matter, the star which will be moving away or moving towards the observer, it does not matter, it does not affect the temperature measured by the observer. So from this very example, it is clear that temperature of a body is independent of reference frame. You should mark it. Okay? But what is the physics behind it? This is just an example, and you have told that the temperature is independent of reference frame. But how you can explain it? What is the physics behind it? If you want to know the physics behind it, that is the actual reason how we can say that temperature does not depend on the reference frame from which the observer measures it, then how we can explain it? For this, you have to go into a deep idea of temperature. What is the temperature? What is its real meaning? Actually, you have definitely studied kinetic theory of matters. And according to kinetic theory of matters, the molecules or the particles of a matter are always in random motion. According to classical physics, there is only one temperature, which is 0 Kelvin, which is also called absolute zero. According to classical physics, at this very temperature, the molecules are completely at rest. But when T is not equal to 0 K, the molecules are in random motion. Mark it, random motion. And according to kinetic theory of matter, temperature is simply the measure of random translational kinetic energy of the molecules. Can you remember a formula? In kinetic theory of gases, we study that the average translational kinetic energy E per molecule, the average translational kinetic energy of a molecule is given by E equal to 3 over 2 kT. This is a well-known formula, and definitely you have studied it. Here you know this K is the Boltzmann constant and T is temperature. So you can see that this E is proportional to T, and that's why we simply say that the temperature is the measure of average translational kinetic energy of molecules. Okay. Here the word average translational kinetic energy of the random translational kinetic energy of the molecules. Actually, here this word random is of great importance. Everything is hidden in this word random. Okay. So we say that random bit is very important. For example, let us say if we move an object, let us say that this is an object and we move it with velocity v. Then the body will gain kinetic energy due to its motion, and when the kinetic energy of the body will increase due to its motion, definitely the average translational kinetic energy of its molecule will also increase. But is it kinetic energy due to the random motion of the molecule? Answer is no. Because here when you move the object, then all the molecules move together, not random. When you say random motion of molecules, that means velocity of the molecules with respect to the body. Velocity of the molecule with respect to the body. But here you are considering that body is moving, this is called mass motion. And due to mass motion, the molecule will have also kinetic energy, but that kinetic energy is not the measure of temperature. That is not the measure of temperature. The kinetic energy due to the random motion, that is due to the motion of the molecules with respect to the body, that is responsible for temperature. Okay. And so you can say that actually when you define that temperature, the energy used are those in the rest frame of the object. That energy is actually the measure of temperature. So whenever temperature will be measured, you have to measure the energy of the molecules with respect to the body, and that is never changed in accordance with our frame of reference of the observer. And that's why we simply say that temperature does not depend on the reference frame situating in which the observer measures the temperature. Okay. So finally we conclude that temperature is independent of reference frame. Okay. All these things I have mentioned it here. I am just giving just going to read it. You can see here the random bit is important. If you move an object, you increase its kinetic energy and therefore must increase the average translational kinetic energy of its molecules. Okay. However, this is not random. All the molecules are moving together. The random bit means that you take into account only the velocity of molecules relative to the velocity of whole object when defining the temperature. Okay. In other words, you can say that in defining temperature, the energies used are those in the rest frame of the object. Okay. And so temperature is the measure of average translational kinetic energy due to the random motion of the molecules. And that random motion is relative to the object. And that's why we say that it does not matter that from which frame you are measuring the temperature. And finally we conclude that temperature is independent. Temperature of a body is completely independent of the reference frame in which the observer is situated to measure the temperature. Okay. And so finally we can conclude from this. If you consider there are two objects, let us say this object is A and this object is B. Okay. And if these two objects will be in thermal equilibrium, what is the necessary and sufficient condition? You know, for thermal equilibrium, the necessary and sufficient condition is that temperature of both the objects must be equal. So if you consider that TA and TB are the temperature of objects A and B, then TA is equal to TB. This is the necessary and sufficient condition for thermal equilibrium of these two objects. Okay, this is the necessary and sufficient condition. Okay, but as the value of this TA and TB does not depend on frame, so you can say that if the two bodies are in thermal equilibrium in a particular frame, then these two bodies will be in thermal equilibrium in all reference frame. Okay, in all reference frame. It is clear or not? If two bodies are in thermal equilibrium in a particular frame, let us say a frame S, then it will be in thermal equilibrium in all reference frames. Okay, so I hope you have definitely a clear-cut explanation of your doubt that temperature is frame dependent or not. What is the answer? Answer is temperature is not frame dependent. And if two bodies are in thermal equilibrium in a particular frame, then they will be in thermal equilibrium in all reference frames. Okay, thank you very much.